Audio, check, check, check. Waiting for audio on YouTube. There it is. All right. Shifting from in-game audio to YouTube audio. Bloop. Okay, YouTube only now, and I'm shutting down Inception. Okay, so everything should be a little bit better. All right. So I'm looking over at the whiteboard here on my avatar's left and running through announcements for March 31st, 2021. So let me start with number 3, actually. Thanks for hanging out with Dr. Lee and listening to the first lecture for Chapter 13. Because of timing and everything, we're shuffling stuff around a little bit. He introduced Chapter 13 before we were able to finish Chapter 18. And to complicate that, we've got another option today as well. So listen close here for your different options. So anyway, he had a good visit. He's back. He's left this morning at 6:15 to go back to New York City. And yeah, if you had a chance to listen to his colloquium, he does research on cybersecurity and in particular the security of containers. And containers is like a virtual machine, not in the Java sense. We use in computer science, we use virtual machine in multiple different ways. One way we use virtual machine is when we talk about the software that runs your Java code. Every architecture, every operating system like Windows, Mac, Linux, they all have to have their own implementation of the Java virtual machine so that Java code written anywhere can run the same way on all the different computers. So if I write a Java program, it's going to work on all different computers because every computer has its own Java virtual machine. That's one way we use the word virtual machine. A completely different concept, same word, it's called virtual machine. And when we talk about that, what we're talking about is a fake computer, a simulated computer that runs as software in another computer. So what you'll have is you'll have like a host operating system, and then you'll run a program that pretends it's another computer inside that host operating system. Common names of software that do this are VMware. That's a commercial virtual machine solution. I think Fusion is another commercial virtual machine solution. There is a free, maybe open source version called VirtualBox or VBox from Oracle that I use a lot. And so what this lets me do is it lets me run a Windows computer on my Mac computer. So I don't have to have a separate Windows computer. I can just run Windows in my Mac computer. I start the virtual machine software and it opens a window and it looks like I'm on a Windows desktop and all the software thinks it's on Windows. It doesn't know any different. Completely separate idea of a virtual machine. Boom, boom. So what Dr. Lee's research is about security in the second kind of virtual machine. And furthermore, the virtual machines have been changed a little bit. So now they're called containers. And containers are like a very, very lightweight virtual machine. It takes a lot less resources to fake out a computer. And because it's this lightweight virtual machine, usually it's just a Linux virtual machine. You don't, I've never heard of people running a Windows container or a Mac container. It's always a Linux container. Anyway, he does cybersecurity research in that. So it was a good colloquium yesterday and had a good time with him. The faculty ate dinner with him yesterday under the tent. Unfortunately, it's a weird situation where we're all eating outside in tents, and it'll be better soon. So that's number 3. Okay, so your choice today. Um, Question, yeah, nothing. Okay. So choice today. I noticed that some of you had been working on the homework for the generics homework, and you may have completed that already. I haven't checked to see if you turned it in. And if you have, then today's lecture probably isn't going to be super helpful for you because what I'm planning on doing in class today is working through implementation of some generic software, like some generic classes. It's going to be very similar to the homework. And if you've already done that, you'd probably find that less than helpful. So what I did is I put together a sequence of asynchronous lectures and self-assessments that wrap up the chapter 16. This is bullet point number 2 on the whiteboard. Bullet point number 2, and it's in Canvas, and let me share that with you on Slack. So what I'm trying to communicate in my under-caffeinated mode here is that today you can opt to do one of 2 things. You can hang around and listen to the lecture, which will continue to be broadcast and we'll be working in Eclipse, Or alternatively, you can check out and on your own, you can go through the sequence of material that is in Canvas that goes a little bit more depth into chapter 16's stuff. So for example, I'll post it up there. Sam, I see your question. Let me take a look at it in a sec. All right, so I feel like I'm not being clear. I'm trying to be clear. Let me just say it one more time, but let me also get my windows to work. Okay. Hang around, listen to a lecture on generics, or go into Canvas and go through a sequence of videos that walk through chapter 16 in a recorded way. In particular, what I go through in these videos is some of the runtime performance issues of linked lists and array lists that I didn't do a very good job of doing in person because of all the technology glitches we had. The last 3 lectures there as well on implementing stacks and queues, implementing queues with circular array, and implementing a hash set are things we didn't get to in class. Each one of the videos has a little self-assessment. Those are practice quizzes, so they're not ones that you have to take, but they're available to you. And this sequence is also going to stay on Canvas. So if you don't want to do it right now, it will be available to do it, over the long weekend if you want. So I'll leave it up there. They're videos that I filmed early on in the pandemic. So um, I don't have a beard, for example. All right, so let me stop for a second and make sure everyone understands the plan for today. Check in on the attendance count and the attendance board either way. Any questions about that? All right. So if you disappear, that's what I'm assuming you're doing. What I'm going to do now is I'm going to shift gears into working with our generics example. And let me, I've got Eclipse already fired up here. Let me put it on the right screen. And let's set up a space for today. Today is 31 and it's 3:31. All right, and let me clear out the stuff from Dr. Lee's lecture. All right, I'm going to set up the project to make sure that we have the libraries in the right spot. Java build path, libraries. For some reason, when I copy it, it always wants to put the library in the module place, which I don't quite understand yet. Okay. Good. All right, everything's up and running. All right, so let me orient myself here with respect to the code. What I want to do, or where we left off last, oops, I was wrong. Application, where we left off last time was talking about generics and the way in which they enable us to write code one time for multiple different classes. And if you'll recall, what they sort of motivated us to do was to think about our algorithms independently from the data, maybe that, particularly when we're talking about data collections, it helps us to think about the way our collections work independently of what's being stored. Because the idea of collections is that you can store data in any kind of data in it, but the collections have different properties. For example, a list and a set, a hash map and different kinds of lists, like an array list or a linked list, different kinds of set, like a hash set or a tree set, different kinds of things like a queue or a stack or a vector. These are all different kinds of ways of doing collections that are pretty much independent of what's being stored in them. In some cases, we can't have anything stored in them, and we were talking about that a little bit when we were talking about specifying some particular, let me see if I can remind you of this by showing it on screen. If you recall, what we did was we were saying that sometimes you want to specify particular aspects of a class. So for example, f extends number. This is saying, well, and someone who wants to use our pair sort of generic, they can put any class they want in there as long as it descends from number. There are certain times when you need this. For example, you may need a class that you can compare. Like you need to be able to say one object is less than or greater than another one. And so you need to implement something like that. You need to say it implements comparable so that you can make sure you can compare. Because sometimes there's nothing inherent about an object that says you have to be able to say it's less than another one. All right. All right. So let's. What I want to do next is I want to do an implementation of a quad. Earlier we had talked about a pair, right? And a pair was one particular way that we could keep two different elements together. We talked about having a height and a weight being stored together in an electronic medical record and putting those in a pair of two ints or two doubles, depending on what units we wanted to use. We also were able to use a pair to keep track of a first name and a last name and to bundle them together. And in a lot of ways, what we were doing with the pair, because taking a pair and doing it as a generic is kind of like making a little helper class. You could imagine having a little helper class where you store things in it and do like a BMI helper class, and it has two instance variables, a weight and a height. Or you could just use a pair, and it's kind of a little bit of a lighter weight way to do things. So let's go ahead and look at a possible way of implementing a quad class. We'll call it quad generic, and we'll put a 0, 1 after it to indicate this is going to be our first possible way of doing it. All right, so basically what a quad is going to do is it's going to keep four things together. Store four pieces of data together. So that we can access them separately, but so they all travel together. So what's like four pieces of data that you might want to keep together? Maybe you want to keep track of the percentage of codons that are in your GPA and your DNA. GPA and DNA, equating those two, isn't that funny? So DNA is made up of four different kinds of codons: A, T, C, G, and U. There are a few nuances to that. And so maybe we want to keep track of the percentage of each one of those codons in your DNA. And so we would keep track of that as a percent of A, percent of C, percent of T, percent of G. That would be four things we would like to travel together. Or maybe we'd like to keep track of four strings. Maybe we'd like to keep track of your name, and we're going to allow someone to have, as part of their name, to have a title, a first name, a middle name, and a last name. And that would be four things we would like to travel together as strings. You know, like Professor Donald J. Patterson. Maybe even makes sense to have more than four, since I'm a third, and that's not in that four. But nevertheless, so okay, so let me just dive into this. All right, so for starters, this is going to be a generic. And so that means that my instance variables are going to have types that are not specified, that are like type variables. And we'll say it's going to be STUNV, and we'll call the different elements that we're going to keep track of. We'll just so that I don't confuse you, we'll call it the first thing. I was going to do something clever, but sometimes clever gets in the way of clarity. And sometimes typos get in the way of clarity. First, second, third, fourth. So these are going to be the four different data types that we're going to keep track of. If we're going to do generics, if we're going to use these sort of type variables, STU and V are like type variables. They don't hold data, but they hold types. Then we need to declare them. And when we declare a type variable for use in our generic, we do it at the top of our class. And we do it with as if someone was calling it, but we are like receiving the type variable. So we put it in a diamond notation, and we say what we want the types to be. Now, we don't know what the user of our class is ultimately going to put in here, but it is available for whatever our user would like to use. And they can mix and match, right? So they can do string, double, integer, Boolean if they want, and have STU and V each be double. We don't really care as the person who's implementing it. We just need to make sure that if someone puts something into the first element, that we're keeping track of that type and making sure that it is integral. Now, the first and second could be the same as well. It could be four strings, in which case the user would say string, 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 string. All right, so just some, I can maybe even get let's see if Eclipse will do it for me. So I've declared some instance variables, and I think I'm just going to ask Eclipse to build this out for me. I'm going to ask it to create a constructor from my fields, and I want my constructor to accept all 4 elements as part of the constructor. I want it to be public, and there we go. It mixed up where it's putting the things, so I'll put it back where I want them. Oops. All right, so I like the instance variables to be at the top. Also, this is just a type, and since they're instance variables, I'm going to go ahead and make them private. All right. You can see that Eclipse generated the constructor for me. When someone calls my quad type, we'll call it with a first, a second, a third, and fourth as part of the constructor process. So when someone uses it, they store data in here. What my constructor is going to do is call any superclass that I might have. A superclass would be implemented here. If I wanted to say I descend from something, I would say either implements, or Java has 2 different ideas of what this means. You can either say implements or extends, and then you have to put the class that you have there. Everything automatically extends from object. This is default, so you don't have to put that in there. Extends object as default. And so when I call super, what I'm calling is I'm calling the constructor on the object class, which doesn't do anything, but it's a good practice to put that as your first element in your constructor. Sip of coffee. The coffee is weak this morning. I feel vulnerable as a result. Okay, 17, 18, 19, 20, I initialize my instance variables. A very common pattern for constructors is to simply initialize your instance variables. And all we're doing is taking what the user passed in and storing it. All right, so now I want to do getters and setters. So I'm going to ask Eclipse to do that for me. I'm going to ask Eclipse under the source tag to generate getters and setters. It's going to ask me which instance variables do I want to generate those for, and I can drill down and say I just want a getter or setter for some of them, but I want to enable all of them. I want getters and setters for all of my variables. Boom. This should all be public. It's going to make it. All right, and so we end up with a straightforward class. When someone calls my get first, I am going to return my instance variable first. We know that the type of first is S, and so what get first returns better be S. And that's going to match up to how our user declared our quad generic. Set first accepts something of type S, because that's what first is. And then this is just kind of straightforward. So notice that this code right here and this code is very similar. So a common pattern is to not reproduce your code. So another thing that you could do is you could do this. You could say set first, first. And this appeals to my nerd, so I don't know why I like doing this, but I just like doing this. I like structuring it here this way. Just have to be careful you get all your pieces right. All right, so that ends up doing the same thing because it ends up running the exact same code. All right, so same thing with second is T. We set our second, it's T. Get third returns U. We set our third, it is U. Get fourth returns V, and set fourth returns V. All right, I don't believe any code unless I've written a test for it. So I'm going to right click on the code and do new JUnit test case. It's going to be quad generic 01, Jupyter 5. That all looks good. What am I going to test? I don't often use Eclipse will write a bunch of stubbed out tests for me. It'll write one test for every method that I have. That's pretty common for JUnit testing. When I'm doing these tests for class though, it's a little bit wordy. So I'm just going to do one. And I'm going to put it over to the side so we can see it. And what I'm going to do is I'm just going to create one. I'm going to say I want a new quad generic version 01. And what am I going to store in it? Let's store a string. Let's just store 4 strings. Let's see, you can't really see that. Let's put this down here. All right. All All right, so this is the definition of my type. I've declared a type. It is both the class name and I've filled in all the generics, and now I've created one long type. I'm going to give it a variable name now. We'll just call it x. And so that's a variable called x. Now I'm going to initialize it as well. I'll do it in 2 steps. X equals a new quad generic, and I'm calling the constructor here. So this is the type, and then I'm calling the constructor, and it's complaining. Why is it complaining? Incorrect number of arguments for type quad STUV. It cannot be parameterized with string. All right, put too many strings in there. 4. It's only 4. It's quad, not a quint. All right, and it's complaining now because I said that my constructor has to take 4. There's my constructor. Has to take the 4. Has to take the 4 things that I want to store. All right, so let's store some strings in here. Let's store Dodger and Lucy and Stanley and Billy the Geeko. All right, so that is testing my constructor, and I'm just going to do a bunch of assertions to make sure it all worked. So I'm going to assert true that Dodger is the same as x.getFirst. So that's just checking to make sure that my constructor stored what I thought it should store and that it returns what I think it's going to return. All right, import assert. Not quite sure what's going on there. What's the problem? The method assert string boolean and the type assert is not applicable for the types x.getFirst. All right, so what it's telling me is assert true. That's someone, I think someone just typed it in. It's assert equals. Someone just say that. So Sam asks, why am I calling super in the constructor? In this case, it's not necessary. It's just good practice, because if you have a superclass, you always want to initialize your superclass, the parent class, the class that you are inheriting from. You always want to give your parent class a chance to initialize itself before the child class initializes itself. Because if there are any instance variables in your parent class that you're depending on, you want them set up before you start working in your child class. So strictly speaking, we don't need super in this class at all, but the reason why we're putting it there is just because it's good practice. It doesn't hurt to put it there, and there are times when it would hurt to have it missing. So it's kind of like a seatbelt. It's better to have it there and not need it than to not have it when you do need it. And also, because that's best practice, Eclipse generated it automatically for me. Okay, so we'll check our 4 different components. And that'll be wrong because it's not the right things. Got to spell them right or it won't match. All right, everything compiles, and let's do coverage of our test. All right, so I don't care about coverage in the test class. What I care about is coverage in the class that I implemented. And just to reiterate, because this is something that a lot of folks are having trouble getting their heads around, over here on the left in the JUnit tests, where I have my test listed here, the fact that it's green in this panel means that the test's completely passed. The fact that it's green in my code has nothing to do with whether the test has passed or not. The reason it's green in my code is because the execution of the program went through these particular lines of code. It doesn't say anything about whether they're right or wrong. So the confusion here is that we're using the same, this is for those of you who care about user interface design, the confusion here is that we're using green in 2 different places to indicate 2 different things. So the same color in 2 different contexts means different things. And naturally, you think that the color green means the same thing because the color green is showing up when you run a test. It's showing up on the left with the test passed, and if you do coverage, it's showing up in your code as well. So naturally, you would think green and red mean the same thing. It's bad user interface design. It's not the same thing. Down here, it means that all of your assertions passed. Here, it means that your code was run. So if we come down here, we can see that get first was run. That was run right here when we called it. We can see that set first was run because that was called in my constructor when I called my constructor. And we should see that actually everything's got set. Yeah, so everything was run. So that's good. My test ran all my code. I have pretty high confidence of this, but actually I know how this class works. And so I actually want to test setting as well, because although I called setting in my constructor, I would like to verify that my set really does what it says it does. So I'm going to do x.set first, and I'm just going to move everything down one. Set first, I will say to x.get second. So I'm going to bump everything up. I'm going to say set the first to what second is. I'm going to set second to what third is. I'm going to set third to what fourth is. And I can't do the same thing with fourth because I don't have a fifth. And if I say x.get first, I'll get the wrong answer because I just overwrote it on line 19. So I'll just manually set fourth to Dodger. And then I can come up here and I can do another set of tests. But now, because we've moved everything around, we need to change which we're testing. Rerun my test by hitting the little green button. Did not pass because something went wrong. Okay, so now this is a good example of seeing my code. The reason why line 24 is red is not because it failed. 25 is not red because it's failed. It's because we never ran line 24. Now they interact, right? So the reason we didn't run 24 is because when we tried to evaluate that get first was Billy, it failed because get first should be the second one, which should be Lucy. So like I totally screwed up that copy. So now if we say Lucy, we should get through that first test. We get through our first test, but we stopped running on line 25. We never ran 26 and 27. All right, so let me fix 26 and 27 to sort of reiterate this point. So we think that third should be Billy, and we think that fourth should be Dodger. So those should be correct. Now if I run my tests again, those lines are red. They're not red because they failed the test. The code execution never got there. The first one is red because the test failed and no further execution happened. So if I fix this one up, let's see, second is third, so Stanley. If I fix this one up, you'll see that all of the code is now going to run. Even though I didn't change 26 and 27, it's now going to pass because code execution is going to pass through those tests correctly, I hope. There we go. Okay, so everything is green now because 25 passed and 26 would have passed if code execution had gotten there, but 25 blocked it from getting any further. So now we've run quad and we've run a test. So I feel pretty good about that. This isn't a guarantee that everything works okay, but it is I'm pretty confident that things are going all right with this code. Let me stop and see if you have any questions for a moment. I'm going to move some code while I'm waiting to see if you have any other questions. No, I'm not. Okay, you all are enraptured with generics as I am. I love them. So I'm going to close my test class and I'm going to close my generic class 1 and we're going to implement a second generic class. But what I'm going to do first is I'm going to assume that we have a pair class and we don't have a pair class, so I need to make a pair class real fast. So pair, I'll call it my pair, set. And we're going to say this has an F and an S. Those are going to be my generic classes. I'll have first and I'll have second, and I'm going to make it private, and I'm going to make it private. And now I'm going to have Eclipse write everything for me. Constructor. Thank you. Good. And I'm going to have it write my getters and setters. Great. And then I'm going to have it clean it up. All right, so there I have a class. I don't believe it unless I've tested it. Fortunately, I already have a bunch of code that tests a quad, so let me just move that over here. Shift to row view. Same process here. I'm just trying to speed it up. Dodger Lucy, first, second, Lucy Dodger. All right, and you gotta say my pair. And something's wrong here. Undefined. It is undefined. Okay, all right, think out loud here. All right, line 11, I declared a variable called x. It is of type myPair. This passed fine. It found the type class and it's generic, and so that's okay. Now when I tried to assign to the variable x an instance of myPair, it's giving me, it's complaining. And the reason it's saying it's complaining is because the constructor myPair string is undefined. If I come over here and I look at myPair, I see that it's got a constructor called myPair. It takes a first and it takes a second, which is of type F and S, and that's string and string here. Oh, it's not saved. It's not saved, so Eclipse is telling me a different version. Okay, great. All right, so I just hadn't saved the files. So now I'm just going to run the coverage as a JUnit test, make sure I'm testing everything and all my tests pass. Boom, great. Coverage of my class, coverage of my pair test. Now the reason why I did that is because I want to implement my quad in a different way. And we'll go ahead and create another class here. Call it quad generic 02. And we'll put it down here in row orientation so you can see the two. We want the same thing, so we want it to be used roughly in the same way. We want STUNV to be 4 different type parameters, and we're going to go ahead and store it in a slightly different way. This architecture here has the quad working all by itself with instance variables. And now what we're going to do instead is we're going to say, hey, we have this thing called myPair that is my instance variable. It's going to have type S and T as the two things it's storing. And I'm going to say this is my first pair, and I'm going to say this is my second pair. So instead of keeping track of the quad as 4 individual instances, I'm going to leverage the pair class to keep track of 2 pairs. Different architecture, it's fine. Notice though what's happening here. I'm passing down the type parameters deeper and deeper. So actually, let me change this here so you can see what's happening. Let's call these types A, B, C, and D. I can call them anything I want. But see what's happening? I'm accepting A, B, C, and D as when a user uses quad generic 2, they will tell me what A, B, C, and D is. And then when I declare my pair, I pass down what the user said A and B were going to be in my declaration of my first pair. So here I'm acting like an API programmer because I'm using the myPair class. I'm not implementing it. And I'm using it by declaring it with A and B, which are generics themselves. And when myPair A and B is evaluated, A and B are going to get mapped to F and S, and it's all gonna be linked together appropriately. A, B, C, and D in quad. A and B will be in my first pair, so my first instance variable F and S will map to A and B. In my second instance of my pair, F and S will map to C and D because it's a different instance. And so this is an example of using a class repeatedly, a generic class repeatedly with different types. But instead of using it with int or double double or string int, I'm using it with A, B, and C, D. It's beautiful. It's really kind of nice. So then I just have to fill this out. And what I just have to be careful of is I have to be careful of the fact that I want my constructor to look the same. I don't want the person using my class to know that I'm keeping track of things in pairs. So I'll still allow them to enter in a first, second, third, and fourth element as my constructor. But what I'm going to do is I'm going to say first pair equals a new my pair object where I pass in my pair A, B, where I pass in first and second. And second pair will be of type CD, so two different types with third and fourth. All right, so then I have to take my getters and setters and I have to treat them slightly differently because I still want it to look like we're doing the same thing, even though we're architecting it in a different way. So when we get first, we know first is going to be A, and the way that I'm going to get the first back is I'm going to say first pair dot get first. And the way I would set first again would be A, and I would say this dot first pair dot set first. Yep. All right, so trying to clean up second here. Trying to do it fast, but can't figure out how to do it fast. Oh, second is still, so get second in the quad is still in the first pair. And set second in the quad is still in the first pair. So you got to keep track of what the user of your quad thinks and what you as the implementer thinks in your pair class. So get third is the first pair, get is the second pair, get first, and set third is going to be third. It is going to be the second pair set first. And then we do the same thing with the fourth. There we go. All right, so that should clean it all up. I don't believe it unless I've written a test for it. And so quad generic 2, make me a new test, Eclipse, do my bidding. Great, there's my test skeleton, put it in row orientation, save everything. And the quad is a quad, so I'm just going to take my whole test from quad generic 1 and I'm going to rerun it, but I'm just going to test generic 2. So when I make my object, it's just going to be a 2, but it should work fine. All right, so there's my test. I'm going to do coverage as a JUnit test. Boom, everything passes. You can see quad generic, all the lines of code got run. All right, so, you can mix and match these as well. If you wanted to, you could do a pair. You could do first and second be instance variables and third and fourth be a pair if you wanted. I mean, that's not very elegant, but you could do it that way. Yeah, so I suppose there are other ways as well. Let's see, there's something else I was going to say about that. Let me put them side by side so you can kind of see the differences. All right, so there's your differences in your definitions, and the same class was implemented two different ways. Those are options. Oh, I know what I wanted to show you. Let's save it all. Let me see if you have any questions. Questions, comments? Double broadcasting for a second. Questions or comments? All right. Let me do one subtle thing before we shift gears and go back to our slide deck. As part of the mental model of what a quad is in this case, by design and by architecture, and that would have to be reflected in the documentation and in the use cases as well, a quad is keeping track of 4 different data elements for the user. It's bundling them together, and it's giving the user the ability to give different types to each one of those objects. We could also imagine that we had a different idea about what a quad was. This is a different architecture, a different design decision. One isn't right and one isn't wrong. It's just 2 different designs entirely. So here's a different way that we could think about what a quad is. A quad could be 4 different pieces of data stored together, but we're going to insist that they all have the same type. They can be generic, it can be a generic type, but all 4 of those data elements have to be the same type, and I want to enforce that. All right, so let's tweak one of our classes to show you what that would be like. I'm going to duplicate quad generic 2 by doing copy and then doing paste. I'm going to call it quad generic 03, and I'm going to load it up. Now this is a different idea of what a quad would be. I'll put it in here. A quad where we are, well, this is a weird way to write a documentation because I'm writing to you, not to the person using the class. But okay, so anyway, I'm writing for you guys, not for someone who's reading the class. A quad where we are going to enforce homogeneity of type. Did I spell it wrong? Homogeneity. There we go. All right. Right now, quad 3, you can use 4 different types. I don't want that. I want to only be able to use one type. Okay, so that would be sort of what you might expect it's going to be like, but there's no need to do that because you only need one type. So we're going to remove all those and say when we declare a quad generic 4, we're going to insist on being passed in one type, but then we're going to use that type 4 different times. So we simply say my pair AA because we're using the class as like saying my pair string string. And then we're going to come in here and we're just going to enforce that in our constructor, all 4 things being passed in are the same type. And then finally, we're going to make our instance variables with our new reserved word of the same type. And we're going to set our return type so that we make sure that everything is working with the same type. All right. So now we've implemented a kind of quad where we enforce that all 4 things have to have the same type. I don't believe it unless I've written a test for it. So let's make that test. Put it side by side. I'm going to re-leverage the previous code. I'm going to grab the test from that case. All right, and now we kind of see that my previous tests maybe weren't great, because probably what I should have done in my previous tests would be to use 4 different types. So maybe I'll go back and fix that in one sec. But to use our quad generic 3, we're going to have a problem here. It's going to say, hey, that's not the way that that generic is written. You're only supposed to supply one type that all 4 of your elements are going to match. Again, when we create our instance variables, you only need one type to declare this type, one subtype. And now, and if we use the right class, now the test should work fine because all the guts are the same. All we did was change the generic layout. So if we run our coverage as a JUnit test, you see that we ran our variant smoothly. And because I'm OCD about it, I now know that my test here was not very good because I used 4 different types, and so that isn't really testing everything the way I would like to. Even though it passed the test, I didn't write a test that confirmed it. So I'm just going to change a few of these to just see how it works out. Test 2. So the second thing has to be an integer, so I better make that like a 1. And the third thing has to be a double, so I better make that like 4.0. And when I test what it is, I better make sure it's a 1. And when I test what it is, I better make sure it's 4.0. Of course, what do we know about doubles? Do we test doubles with an equals? And the chorus of students all says, no, we never test doubles with equals because we might have small rounding errors that cause it to be technically not equal but equivalent as well. So let's see, there is an assert equals that does this. Shoot, assert equals, oh, maybe we just do this. I forget my type. Yeah, there we go, great. All right, and the type here has to be integer and double. Hey, what was it? Hey, Professor Patterson, what was that move you just did on 16? Okay, so there is a kind of assert equals that works with doubles where you put in the first thing that you think should be equal, so we think it should be 4, and you put in the second thing that you think should be equal, so we do get fourth, and then the third thing, if the first 2 things are doubles, you can pass in a third thing, which is your tolerance, which is how close do they actually have to be considered equal. So that's something that's built into JUnit testing. That's something that you should get used to in working with doubles. All right, so then we need to prove that we're changing it. So we can change Dodger to Billy, set second to 2, set third to Lucy, the cat, set fourth equal to math.py. And then we just have to make sure that our changes worked. This is what our test is exactly doing. We're just checking to make sure that the code worked between calls. Lucy, 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 and the pie with diamonds. Wow, 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 when you're tired, you're delirious. Okay, let's see if it works now using 4 different types. And growing in wisdom and stature and a little bit of grace of God, and it passes. Great. We see that none of the lines of code in generic 3 ran. That's why it's red. It's not red because it failed. It's red because it didn't run. If we go into generic 2, we see that everything in generic 2 ran. So we're good to go. All right. That's our foray into writing our quad generics. Sam asked a question about the problem set. So let me answer that. He asked a question in Slack about the skeleton for Episteme 8. And let me just dig into that and give him an answer. The question was, is the skeleton project for Episteme 8 only meant to include the 4 test classes? Should we be making the 3 generic classes from scratch? Just want to check. And the answer, I'm just verifying, the answer is yes, that's correct. You should be making a pair class, a quad class, and a triple class on your own from scratch, but in such a way that when they're placed in the same directory as multi-test, pair test, quad test, and triple test, they work okay. Now, of course, this is writing your different classes, generic classes yourself, but most of the time you're going to be using generic classes. So we can just show you real quick how to do that. Now that we understand a little bit about what we're doing. Oops, I meant to, oh, it did do a main. Good for me. Okay. So now if we say something like linked list string, I hope you have a better idea about what's happening here. We're creating a linked list where we can add string to it. And that generic, when the implementer of linked list wrote it, had a generic there that's filled in. And that's why we're enforcing the Lucy here. If we had created a linked list instead that had doubles, we would have a problem here. We get an error because the generic enforcement says, hey, Lucy's not a string. Lucy's a double, so get on it. All right. The thing that I think is kind of most exciting about this, I mean, there are lots of things I love about this, but one of the things about this is that you can compose classes very, very quickly this way. Sometimes it can get a little out of hand, and you should create a separate object to do this, but you can compose classes very quickly. So let's say, for example, I want to make a map that maps between a pair of strings. Sorry, that's my broadcast. That maps between a pair of strings and returns a quad of integer, double, string, and string. That's okay, I can do that. I just have to import map. So I'm mixing and matching. I'm taking the Java utility generic map, which maps from a key. In this case, the key is a pair of strings. So maybe in this case, what we're trying to do is we're going to map a first name and a last name, and what we're going to get back is some health data. An integer, maybe that's the year of birth, and a double, maybe that's their weight, and maybe two strings, which indicates prescriptions are on or something. I don't know. But you can build this class very quickly by using generics. And then when you want to actually instantiate it, you have to be careful because you say C equals a new, and we have to have a specific implementation of a map that we're picking. So a new hash map, and that hash map is going to map between a myPair string and a quad generic string, and it's a constructor. And I just need to import hash map. And now I have this thing where I can put a new myPair and a new quad generic. I forget what we said, like 1972, and my weight, we'll pretend it's 180. We'll wish it was 180. String my prescription, I am on a statin, and not true, just making this up. And I am on, I don't know, what's some like high performance drug. I'm on Super X, which is a made up drug. Okay, so very quickly, I'm able to create that, and I can, look things up that way. So really powerful. Why is it giving me an error? It's not giving me an error now. I don't know what happened. All right. Thinking through. Okay, so let's come back here and just wrap up. Bits of details. Generic types are atomic, and this relates to inheritance of types. So in the first case, you can see I'm creating something of type object, the superclass, everything superclass. I'm just creating it. Doesn't do a whole lot. It's just kind of a reference to some memory. And then I'm creating an integer using the object-oriented version of integer. So I'll say a new integer, which is going to have the value of 10. And if I say that some object equals some integer, that's okay because some integer inherits from object. And so if it inherits from object and I need a reference to an object, then some object can point at some integer and that's fine. Likewise, now in the second example, if there's some method implemented that accepts an integer, I can pass in, accepts a number, I'm sorry, I can pass in anything that descends from number. For example, I can call an integer. So I, on the fly, create a new integer of type 10 and pass that as the parameter some method. That's fine because integer descends from number. And so everything that number has, integer has, and integer has more. Same thing with double. Everything that number has, a double has, and double has more. So it's okay to use a double when you need a number. Sorry, phone call. In the third case, this is okay as well. I'm going to create, wait, let me make sure it is okay. Yeah, this is okay as well. I'm going to create a integer and I'm going to create a double. I'm going to create a pair that consists of numbers. And when I instantiate it as part of my constructor, I'm going to pass in the integer and the double. I need a number for the first element, assuming my constructor is normal here. I need a number for the first element, and I need a number for the second element. An integer descends from double, and an integer descends from number, and a double descends from number. So this is great. But you can't just inherit a portion of a type. So here's an example of what you can't do. So on the left side at the bottom with the check at the box, you can see that a double can be used whenever a number is needed, and a number can be used whenever an object is needed. However, in the second column on the bottom, you cannot do this. You can't say, I have a vector of doubles, and therefore I can use a vector of doubles whenever I need a vector of numbers. No, and I can't use a vector of numbers whenever I need a vector of objects. The reason why is because although in our head we understand that number descends from object and double descends from number, the way the compiler works is the compiler thinks that thing is one big type. When it works with it, it is a vector number. It is not a vector filled with numbers. That's how we build it, but when the compiler works with it, it treats it as one big type. So the relationship on the right is how the compiler views this. Vector number descends from object because everything does, and vector double descends from object because everything does. But once we compose that type, there's not a relationship that is carried over between the sub pieces of the type, for example. When we compose a type, you're creating a completely new type, and any relationships between the subtypes don't remain. And you can see this in the code at the top, where we accept a vector of numbers as in our sum method. And then in the second example, we try and create a vector of doubles and we try and pass it into the sum method. And Eclipse gives us a complaint because even though it feels like a double descends from a number, and so a vector of doubles should be fine descending from a vector of numbers, it doesn't. It's one whole type. You can't break apart the pieces of the type. And then I'll leave this. I'll put the slides are up from the last lecture, and I will leave this here since we're running out of time. I'll leave this here as an exercise for you. The question is, how would you call this generic method? There's one other way of declaring a generic type, which is as a method instead of as an entire class. And this is an example of doing that as a method. You can see that the bracket T is being passed in as part of the method signature, not as part of the class signature. And that means that this bracket T only works in the context of this fill method, not in the context of the whole class. All right. Okay, so couple things to work on if you would like on your own at the end there. Here's the summary. 10,000 feet, Generics are enabling our types to be parameterized, our classes and our interfaces. When we think about it that way, the input to our generics are types, like number, double, string. The output of our generics are new types, like linked list string, or vector string, or pair string string. They're similar to parameters and methods, but we're not passing in data. We're composing types. It's a little bit better to think about it as composing a type rather than passing a type as a parameter. And in many ways, they are best described as metadata. They're data about data. The types are data about the data that you're using. And the main good thing about it is they let us reuse the same code with different types of input, just depending on how we declare it. We write less code. We can reuse code like our pair class code or a our pair class can be used for all different kinds of types. We only need to write it one time. So therefore, we are able to implement generic algorithms independent of the type. Java, it makes this a better language because it enables Java to do stronger type checks at compile time. So the handsome gentleman with the scarf doesn't suffer undue error. The developer deals with it all, and when they ship their code, you don't get runtime errors. More errors are found at compile time through static checking as a result. That's it. So thank you for your attention. Follow-ups from today. I'll stick around for a second. If you want me to share the code with you, because we didn't do that in Saros, I realize I'll do that right now if you want it. Otherwise, thank you for your attention. No class on Friday. I will see you a week from today. Holy smokes. And we're going to kick off with Drone World next week and then fill out our recursion work. Last chance for questions. Shifting to in-game. Any questions? Double broadcasting for a second. I'm keeping Eclipse open. I'm going to continue talking in game, but I'm going to wrap up our broadcast. So it is March 31st. We're in the midst of a pandemic, talking about generics. We've wrapped up generics today. On Canvas, you have the walkthrough from chapter 16 if you want to use that as a review. Some self-assessments that are not going to be graded, but they've got some nice practice quizzes in there. I will see you in a week from today. And yeah, great. Transitioning. So long, YouTube.